Hello, everyone. My name is Suraj Ramachandrappa. I'm a product manager working at Script located in Bochum in Germany. A bit of myself with regard to my role. So I joined the product management team earlier this year in January. But previously, I have more than 4 years experience when working with automotive security and embedded systems. And I'm really looking forward to an active presentation and an interactive discussion with everyone. So thank you very much.
Thanks, Suraj. A warm welcome from my side as well. I'm Rohan Pandit, and I'm working as a product owner at Script in Stuttgart. And I have joined the product owner and product management team of Script in June 2018, post my MBA. Prior to that, I was also into software development on embedded systems, mainly in the industrial domain. And I'm looking forward to having a good session today. So let's get started. So we want to look at the future trends in the industry, specifically focused on the hardware security module. And we will first set the stage by looking at the market trends, specifically on the EE architecture and how it's evolving over time. Then we look into the drivers for the new security hardware architecture and how we can address these challenges that we foresee in the near term. Then we also focus on the hypervisors, which are also resolving some of the challenges that we foresee with the new architecture changes. And finally, then we have a look at the future challenges, which are focusing on the long-term challenges that we see, and then we end with the Q&A. So for the market trends, I will hand it over again to Suraj.
Thank you very much, Rohan. I think before we get started within the market trends, I think a bit of context for the presentation. So this is more of an info session with regards to the trends and the direction in which the market is moving with regards to next generation or new age EE architectures and the challenges and a brief introduction into the solution space which will be presented. Of course, with regards to, this is not an open advertisement of any solution as such, but of course, if you would like to get to know more, you can always reach out back to us. So, but I would say we wanted to keep a very open presentation here with respect to the content presented, and hoping also for a very fruitful feedback session on that end as well. So the next slide, please, Ron. Thank you. So where are we at the moment? So right now we see that we are slowly receiving new EE requirements from OEMs or from manufacturers who are thinking about an extended vehicle network and correspondingly security being a part of this network to secure the expanded network and communication channels, and while maintaining the confidentiality and authenticity of the data. So at the moment, we see a classic network with a central gateway, and each of these central gateway systems has a corresponding controller from a respective domain. So here, from one of the examples we see here is a central gateway network governed by a microcontroller, and it's interfaced through the CAN network through various domains within the car. So, for example, the powertrain, the battery system, brake systems, the OBD, etc., etc. So at the moment, we just have a central gateway system for enabling cross-domain communication. And what is the security along the communication network? It's more or less along the central gateways to do with the CAN firewall system and more like secure onboard communication. However, in the near future, we see in the short to the middle term development and introduction of zone and vehicle controllers, with a next level of abstraction. So you have a middle layer of a domain controller, which is then correspondingly connected to a central gateway system. And of course, you have different communication network aspects, which is not the focus here. Here, the focus more to do with the security. So what we see is, of course, if you have a broader network, you have a correspondingly increased bandwidth demand for enabling secure onboard communication. You require security hardening. So as a next layer, as a next level attacker model, sorry, because you now have a whole new layer, a whole new bunch of interfaces which are available within the expanded network. So either through the central gateway system or within the domain controllers itself. And it's very important that the security hardening addresses addresses the security concepts in effect so as to protect the overall system to a degree as safe as possible, or as secure as possible in this case, and safe. So you perform a trusted chain of operations with an assumption that the host is always can be taken over by an attacker, and you look to isolate applications. So in this case, for example, through using the HSM model itself, or if you want to have a hardware-based protection, so through partitions, etc. And of course, you need to have a crypto agility for when you have a domain controller-based network here, or a zone vehicle controller-based network, where attackers are constantly probing new ways to enter and maliciously attack vehicle networks. So you always need to update the crypto algorithms and stay ahead of the curve faster than new attacks are applied. So that means you need to ensure that you have the capability to carry out dynamic updates in the field, maybe partial here in this case. So for example, with the concepts of firmware over the air updates, and of course with the coming onset of, for example, new autonomous vehicles, etc. This is also a field of interest where we see a lot of movement taking place, and which is justified because these are the requirements of the future. And of course, security measures against post-quantum based attack vectors, which is, as we will also shortly see later, pose one of the biggest challenges to security in itself, because it drastically reduces the effectiveness of algorithms and encryption methods, which we currently use as the de facto standard, by a significant factor. So you need to ensure that you have the security enabled against these upcoming threat vectors or attack vectors. And in the long future, you see, for example, using some sort of a redundancy system with ring-based network architectures, an introduction of, say, vehicle computers here using high-performance, security-enhanced high-performance microprocessors or system-on-chips. The next slide, please. Yes, so this was the more of a theoretical introduction into the market trend. So now we see as to the projection and the quantification as to is this actually justified as our hypothesis. So what does the facts and figures or the market generally speaking? So we expect our accumulated aggregate growth rate of approximately 68% for the zone controller market between 2020 and 2025. So as you can see from the figure on the left, so with respect to the base case, so there's a significant jump from the current state of art as is. So for example, this is considered 2020, but so you see that there is a significant leap from about 2 to 26 controllers for the zone control network, followed by approximately up to 68 controllers, 68 zone controllers in 2030, which is reached. So that's a massive new market, which is heading, a massive new market growth, which is expected. And this is even more steeper or even more larger. For example, a specific use case here, which is considered for autonomous vehicles. We see that there is a jump of, let's say here, from 21 zone controllers in 2025 to approximately 111 in 2030. So from the forecasts and from the projections that we see, there is a huge market for this, and it is justifiable because OEMs and manufacturers, as well as all the players involved in the security market, they know that the expanding the E architecture, it suffices to provide a high performance requirement, and it satisfies to provide the security and the safety concerns as well. So I haven't really spoken about the safety aspect yet till now. So within the new EE architecture, of course, it's expected that it satisfies all the safety requirements. So still now it is up till ASIL B, but of course it expands and must satisfy until ASIL D as well, where it needs to fulfill, for example, using of the hardware security module in applications with safety critical functions, and it needs to ensure freedom from interference. And we will get to this in the upcoming slides. The next slide, please, Rohan. Yes, so till now we focused on the market aspect. So we were focusing on the external aspects or the external inputs, what was projected for the zone controller market and with respect to new next generation EE architectures. However, with regards to the HSM, however, we need to see also the other drivers which are leading to explicit technical requirements. So we are deriving requirements based on these drivers, so which is going to be summarized and briefly explained upon in the next slide. Thank you. So the one on the left-hand side are the requirements or the drivers, I would say rather, and the ones on the right-hand side are technical implementations which are being driven by these market factors, or not just market factors, but requirements evolution, I would say. So these have just been summarized here, and I'm not going to be going too deep into the technical requirements, the technical drivers here in essence, but this will just be like briefly touched upon each point. So for example, the first one with new EE architecture, it's expected because the OEMs are moving, as I previously pointed out, the OEMs are moving forward towards new implementations with regards to domain and zone controllers, which has the corresponding impact that you increase thereby your network communication because you have now a layer on layer approach. And this also puts an additional new load onto the network. Therefore, it needs to ensure sufficient bandwidth, and the bandwidth requirements come under one of the drivers here. As a driver, of course, you need to ensure that when you're in the field, you have the capacity and the capability to ensure dynamic partial firmware updates. So for example, when you're in the vehicle and across multiple driving cycles, you ensure a firmware update. So using the firmware over the air update use case in this case, and while ensuring that the main application of the hardware security module is not compromised or the functionality it needs to enable. Functional safety, so very critical aspect. If it satisfies the ISO 26262 norms with regards to the various ASIL classifications of the controller units of the ECUs, if it can ensure the freedom from interference, safety concerns, and of course you need to also on the other side assume that when you have a HSM and a host controller, the host is no longer regarded as a trusted entity, while the HSM in itself is a hardware-based trust anchor. So the host is considered as not secure. So you always run under the assumption, and what we operate is that the host can be overrun and can be taken over, and we need to be ready for these use cases as well. You have a wider attack surface as a result, and of course you need to ensure sufficient security hardening here as one of the main driver. The software in itself is not going to be developed by one single supplier. So there are a lot of stakeholders involved, from silicon vendors to various suppliers on tier 1 and tier 2, who all need to put in the software, which is then all integrated into into the new requirements of the E architecture. And this is all done in an agile context. So these drivers drive technical requirements and implementations to support them, such as separate hardware cryptographic accelerators. So for example, these satellites in high-end microcontrollers, strongly increased crypto hardware support. So we will also touch upon this in the coming slides, an increased program flash, virtualization support in hardware, and of course, an SLD compliant hardware design, and also enabling it through software through, for example, the HSM. The next slide, please. Thank you. So what are some of the challenges also which are caused by increasing host software complexity? So in the future, the requirements in the collaboration models will demand I think, a bit of repetition, but it also is important to understand the problem and the why before we go on to the how and what. So firstly, the isolation of safety use cases here. So you are looking to operate, the operating environment here is one with safety critical applications. And of course, it needs to support the network in itself from inputs coming in from multiple controllers across the network. So you need to have a multi-core and multi-session support on current HSM hardware architectures. You need to ensure a separate and dynamic software update, maybe simply through the development using DevOps or agile development, or feature activation and firmware over-the-air updates. And of course, you need to ensure isolation of security context. So for example, you limit the vulnerability or the exposure, and you enable this hardware security model system to be as secure as possible and isolated with respect to the HSM in itself housing the supplier or customer specific secrets. So what are the consequences here? For example, one implementation method which has been realized is through virtualization with a hardware. So as you can see from the figure, it's more like a next layer of abstraction at the hardware level, where where each of the host applications are supported by individual virtual machines, which interact through the hypervisor and communicate with the HSM and HSM firmware enables all of this. And of course, you have an increased HSM flash demand as you have now increasingly larger number of storage of complex certificate trees. And of course, you have a higher number of keys and multiple sets to be stored onto the HSM itself. Now, Rowan is going to talk more about the virtualization and also with regards to the solution space that we see and the post challenges. Over to you, Rowan.
Thanks, Suraj. Now let's look at how we can overcome all the challenges that Suraj has spoke in the previous slides. So I think the key challenge that all automotive manufacturers see right now is to attain a good balance between the security and the performance requirements. Since both of them impact each other, it's essential to find a good balance between those two. What do we mean when we talk about security requirements? So HSM acts as a root of trust and ensures the overall security of the system. And the other requirement, or the other key requirement, is to ensure isolation between host and the HSM to ensure freedom from interference. From a performance point of view, of course, the system needs to be performant enough to meet the timing requirements of the OEMs. And here our broadband data exchange between the host and HSM is essential. Currently, what we see is a bottleneck here, which is the host to HSM bridge communication, which is affecting the performance and the security of the whole system. In order to address this, what we see in the new generation of targets is the addition of the new security IP, or the hardware accelerators that we have been mentioning in the previous slides as well, which give us the opportunity to perform some crypto operations on the hardware accelerator module itself. Of course, the security has to be ensured here. So the HSM is responsible for the key loading and calculation part, so that these keys can be used by the hardware accelerators to perform the CMAC operations. In addition to this, we also have the opportunity to have a clearer safe CMAC path as well. Safe CMAC is essentially a feature that ensures that the provided CMACs are in ASIL-D quality, and this can then fulfill the safety goals of the OEMs to ensure that there is no false SMAC which is verified as valid, and FFI, or freedom from interference, is ensured between the HSM and the host side. So this is one of the challenges that we have addressed by having a hardware accelerator implementation which is provided by the silicon vendors. All right, then let's get moving on. Then we move on to the topic of hypervisors. Hypervisors essentially is a software or a hardware that creates and runs different virtual machines. And the use of hypervisors is essential to create a virtual environment in the system and address the limitations and the challenges that we have foreseen in the near to midterm. Then let's have a look at what are some of the key use cases. So one of the first use case that we see here is with respect to integration of software from different vendors. We see that a lot of OEMs have several tier 1 and tier 2s who are providing different softwares, which has to be integrated into the ECU to provide an end solution at the end. And this is ensured by the hypervisors by providing an easy option to protect the IP and also guarantee freedom from interference. This is the first use case. The other key use case is the use of legacy ECUs. A lot of projects will be moving from the legacy ECUs onto this new generation of targets, and they need to ensure that the hypervisor solution is also supported on this legacy ECUs, which may also use a non-AUTOSAR environment. So this is also important for several projects. Besides that, we also see another use case is regarding the support for independent software update cycles. So what this offers is the option to update a single module within the system without affecting the other modules. So hypervisor ensures that a single module could be updated without causing a big impact on the overall system in general. Another use case is support for homologation. Homologation is essentially a process of certifying that a particular vehicle is roadworthy and matches the specified criteria laid out by the government. This is very important for the vehicles which are being imported into a specific country, and hypervisor offers the support to ensure that the specified criteria are adhered to. Last but not the least, safety and security use cases. So hardware enforced freedom from interference between the virtual machines can be realized using the hypervisors, and the HSM can be used to ensure that there is isolations between the VMs, and the system needs to be designed in a way that it meets the safety and security use cases. So these are some of the use cases that we have identified. Now we can have a look at some of the hypervisor solutions that are available on the market. So here I have provided a list of the hypervisors that are offered by ETAS. And we see here that there are 3 hypervisor solutions offered by ETAS based on the environment that they are supporting. So the first one is, of course, the lightweight hypervisors, which is focusing on the microcontrollers that we are using today. This is a ETAS developed product and has support for gas environments with bare metal and RTOS. This is a fairly lightweight version, hence it has some overheads, but of course it also then has the limitation that it cannot handle interrupts on virtual machines. Currently, the lightweight hypervisor has been ported on the ST devices, specifically the SPC58 series, and also on the Oryx second generation targets. So this is already in place and can be provided from ETAS. Then we move on to the RTA hypervisor, which is focusing on the new generation of microcontrollers. Here we have a proof of concept available, and the product is still in development, and we continue to make progress by collaborating with several partners here. The guest environment again is the RTOS, and it also has a few small overheads as well. But also the restriction that we see here is the potential need for paravirtualization. Paravirtualization essentially is identical to the layer that is underlying, which is the hardware software interface. So this is an additional layer or software interface towards the virtual machines. Although paravirtualization offers better performance in some cases, it also has the disadvantages of adapting the OS on the guest side and also some modifications on the hypervisor side. Currently, we already have some prototypes available for the RTA hypervisor for the ST Stellar devices and the Renesas E2 devices. We also have plans to port this solution on some of the newer targets as well. Then finally, we have the VRTE solution. This is targeting the system on chip devices or the microcomputers. This is a product that is being resold by ETAS, or which is a Lynx product. And the guest environment here are different OSs like the RTOS, Linux, LynxOS, etc. Of course, this also has similar overheads and restrictions like the RTA hypervisor, which also needs the potential need for paravirtualization. Of course, this, like I said, is focusing on the system on chip devices, and we see a lot of Intel and Xilinx and XP devices that are supported here. So these are the different hypervisor solutions that are on offer today. Now let's look at the future challenges. So we have had a look at the near-term challenges. What is upcoming in the future? So the biggest challenge that the industry sees today is the post-quantum cryptography. So this is a challenge which will pose a severe security threat to the current crypto algorithms that are being used. An example would be lowering the security level for AES factor by 2 times. So this will make it much more easier to break into existing algorithms such as ECC and RSA. Citing these threats, several of the OEMs such as Daimler have already started including some PQC requirements in their security specification. So this is becoming more and more relevant, and a lot of OEMs have already realized this and started including specific requirements addressing the PQC. Also, what is important is that NIST is already in the process of selecting certain PQC algorithm candidates, and a decision is expected by mid of 2022. This will make it much more easier since it will be a standard in the industry, which can be then implemented and offered as a solution to our customers. So in general, all ECUs need to establish a secure design to be prepared against attacks by post-quantum computers. Consequently, the HSM also has to adapt and create a system design which is robust against such attacks. And we have already started working in this direction to ensure that we have a future-ready solution. So finally, to end the presentation, I would say that the automotive cybersecurity industry is evolving fast, which implies that there are several challenges that we see in the future to ensure safety and security on the ECUs. But of course, such challenges motivate us to provide even more robust and state-of-the-art solutions. And this is what we are striving to do and preparing ourselves so that we have a future-ready solution. Thank you.
Goodbye, everybody.